Hey, Calc 3 friends. So here is a video where I'm going to go through what I have titled here is multiple integration test review. But this is really the last video I'm going to give you about multiple integrals, so we can go over and finish that stuff up. And then next week, I will probably work on, or maybe soon, I don't know. Time passes weirdly. Um, but anyways, my next videos will be on our very last unit, which is line integrals and vector fields. So I'm going to try to make those videos myself. Do some exist online? Yes, but it would take me 3 hours to find a good one, and a lot of the videos that exist online don't explain it the way I do. So I don't know. You're probably going to get a video of me, but I may also send you to some other places with people who are better at graphics and staying organized than I am. But we'll see. So I hope everybody's doing well and you're not too overwhelmed. I know yesterday I got overwhelmed. How overwhelmed, might you ask? So overwhelmed that I used our sous vide cooker to pasteurize raw eggs. That way, when I make cookie dough, I can eat it out of the bowl without worrying about getting salmonella. So, how stressed out did I get? So stressed out that I pre prepped eggs to be able to eat cookie dough out of the bowl. So, that's a limit that I've reached. All right. So you're going to find this multiple integration test review in your probably I'm going to put it in files, and I have another video telling you where to find all that stuff. I won't put it here, but you can find this in files and either print it and follow along, or you can just follow along on like a separate sheet of paper. You need to figure out what works for you. And I'm going to be honest, that's what this week is kind of for. This first couple weeks that we're dealing with this, it's for figuring out, yeah, how do I learn? What do I do to learn that works for me? So you'll figure that out on your own, I guess. So if you have access to a printer, print this out. If you don't, I would say have pen and paper nearby and you can figure it out from there. So we're going to go through multiple integration test review and just kind of review what we did 2 weeks ago, which feels like, I don't know, 8.5 months ago at this point. So yeah, that's what I'm doing. I'm going to flip this over and get to work. All right, so when we do this, it says find the volume underneath this thing and above the region whose vertices are those. So things that you need to know here. If you want to find volume, it's going to be the double integral over a region with we're going to call it the height of that solid goes in here in the integrand, dA. R is the region based by these points. So I have 0, 0, 1, 0, 0, 3. So this is the region right here. And that region is both vertically and horizontally simple. So my region doesn't define my order of integration. But I don't know how to take the antiderivative of e to the y squared. So I am definitely going to evaluate this with respect to x first. So I am going to rewrite this as a double integral of 4x e to the y squared dx dy. And since I'm doing dx first, I need to write this region with respect to an x equals equation and go right to left. So my right-hand side, this is the line y equals 3 minus 3x, which is the line x equals 3 minus y divided by 3, also known as 1 minus y over 3. So this slanty line is the right-hand side of my region. So 1 minus y over 3. And this would be the left-hand side of my region, and that's x equals 0. And then y is just numerically bounded between 0 and 3. So now I'm going to evaluate it and say the antiderivative of 4x e to the y squared is 2x squared e to the y squared. And I'm supposed to evaluate that from from 0 to 1 minus y over 3. And then I'm subbing those in for x. So I have 2 times that squared times e to the y squared minus 2 times 0 squared e to the y squared dy. This, though, I'm really just subtracting 0, so it's really just the integral from 0 to 3 of 2 times this e to the y squared dy, and that I'm just going to put in the calculator because remember when we get down to a single integral, we can put it in the calculator. So I have, let's see, can I shrink this? I thought I could shrink this. View, hide large display. No, no, I'm learning here. Stop it. Go away. There we go. That's what I wanted. So I can go math 9, 0 to 3, 2, 1 minus y over 3 squared e to the y squared. Forgot my caret. No, of course. Oh my gosh. This is the worst. Doing this is the worst, and you guys watching it, you're probably going nuts. There we go. Oh, yeah, there you go. Good. I just wanted an answer. 28.2239. 28.2239 is the volume of that surface above the triangle. Yay. All right, so there's question one. So, what did we learn from question one? Because the whole point of this video is honestly to do a review of multiple integrals. So, its volume equals the double integral over a region of some function dA. Okay, so volume is just the integral of a function over a region. 2 says find the surface area of that above the region bound in the first quadrant by the graph of f of x equals 4 minus x squared and the coordinate axes. Okay, so surface area has its own formula, and I am going to pull up the formulas that we need here. So bear with me. And I'm actually going to pull up the final exam formula sheet because I think it's on there. Yep, it's here. Hypothetically. There it is. So the surface area formula is that 1 plus f sub x squared plus f sub y squared square rooted. Okay. So surface area, another big picture idea, is a double integral over a region, but instead of just having the function here, I'm very, very much condensing this formula. There's your surface area formula. Okay. Now, it's over a region, and our region is the first quadrant by 4 minus x squared in the axes. So here's 4 minus x squared. And it's the first quadrant part of that, so it's this piece. That would go up to 4. This would go out to 2. And yeah. Now, please note that this f of x creates the region. That's not the f that's in the integrand. This f I have now used to create the region. I don't need to use it anymore. This is the f for which I take f sub x and f sub y. So I'm going to do that off to the side. F sub x is going to be negative 4x. F sub y is going to be negative 1. So then I need the double integral of the square root of 1 plus f sub x squared plus f sub y squared And now I need to look at that and decide what can I integrate with respect to. I cannot integrate with respect to x very easily because of the radical, but I can integrate very well with respect to y because there are no y's. So I want to deal with this as a dy dx order. So my y bound on top, the top part of this region would be the parabola, and the bottom part would be the x-axis. So this is going to be 4 minus x squared to 0, and x is bound from 0 to 2. All right, now hopefully again that makes sense because I was doing dy first. I had to do top minus bottom, and then the dx part is just the x values. Okay, so now I have to evaluate this sucker. The antiderivative of that would just be this with a y on it. So it's going to be y times the square root of 2 plus 16x squared. And I'm evaluating that from 0 to 4 minus x squared, which is going to give me the integral from 0 to 2. And I'm sorry if you're hearing that dinging. That's my son sending me messages about Fortnite and Animal Crossing. Let's see if I can make that go away. Oh my gosh, stop dinging. Yep, see, Mr. Taco, that's Landon. There, gone. So now I have to plug these in. So I have 4 minus x squared square root 2 plus 16x squared minus 0 times the square root of 2 plus 16x squared. Let's be honest, nobody cares because it's a 0 in front. Dx, and calculator again. 0 to 2. 4 minus x squared square root 2 plus 16x squared dx 18.446. I rounded up to 447 because I felt like it. Okay. So what did we learn from there? Number one, that Landon really wants me to know about Fortnite and Animal Crossing and is sending me links through Google Hangouts. But more importantly than that is that we have a surface area formula, and we can use that to find the surface area of a surface above a certain region. Cool. All right, 3. What's the point of this thing? So if we're going to do 3 here, it says evaluate that integral over the region shown. Okay, so this region is vertically simple until here. That doesn't work. And horizontally simple until here. That doesn't work. This is a perfect chance to do polar. Okay, because in polar, this is just r equals 5, and this is r equals 3, and this is theta equals 0, and that's theta equals pi over 2. So we want to convert this into polar. So what you have to remember is if you have a double integral of a region, dA, when you write it in polar, this becomes f of r cos theta, r sine theta, because x equals r cos theta, y equals r sine theta, and then dA becomes r dr d theta. And since dr comes first, this is 2 radii, and then theta comes next, so that's theta 1 and theta 2. All right, so for our function, I would then have the integral from 0 to pi over 2, from 3 to 5, and xy squared, x becomes r cos theta, y becomes r sine theta and is squared, and dA becomes r dr d theta. So then we have the integral from 0 to pi over 2, 3 to 5 of r to the 4th sine theta cos theta, because I have an r squared, and another r, so that's the r to the 4th, dr d theta. Because remember, this r d theta, it's not like they're all attached. This r joins up with the rest of the integrand, and d theta are your differentials. So now we have this. The antiderivative of r to the fourth with respect to r is 1/5 r to the fifth from 3 to 5. So then I have 5 to the fifth divided by 5 is 5 to the fourth sine theta cos theta minus 3 to the fifth over 5 sine theta cos theta d theta. And then calculator time again. And no, you do not need to be in polar for this to work. You can just stay in your regular mode as long as you're in radians, which I am. 5 to the fourth, which is 625, sine theta cos theta, minus 3 to the fifth over 5 sine theta cos theta d theta. And then that is what was it? 288.2. Fantastic. Okay. I want to do this one page at a time because I don't want these videos to be too humongous. So I'm going to stop there. Your jokes this week are going to come from my kids and just the things happening in my household. So this morning, Landon came downstairs and he said, Mommy, the next time you buy ice cream, I want you to buy me some obese primate. And I said, I'm sorry, what? And he said, I really want to try obese primate ice cream. And again, I said, what? And he said, chunky monkey. So that's the kind of humor that, my 10-year-old has at 7:30 in the morning. All right, new video coming soon.